Hey, welcome to another digital lesson. This time starting chapter 11, section 11.1, and we're going to be talking about comparing numbers. Comparing numbers. Sounds pretty good. Let's go ahead and get into it. Well, there are different numbers out there. Most of the time in this class we've talked about numbers that are positive numbers, but there are also negative numbers out there. Numbers that are less than 0 are called negative numbers. Okay, you can represent both negative and positive numbers on what's called a number line. So this is a number line, and in the middle of all number lines is the number 0. And numbers to the right of 0 are positive numbers, increasing by 1. It's 1, 2, 3, 4, 5, 6, 7, 8. And this number line will continue to go on forever because it has an arrow. And numbers to the left of 0 are called negative numbers, like -1, -2, -3, -4, -5, -6, -7, -8, -9, -10, -11, -12, and I think you get the picture that this number line will continue to go on infinitely, both the positive direction to the right and the negative direction to the left. As numbers go to the right, they continue to get bigger, and numbers go to the left, they actually continue to get smaller. So all of these numbers to the left are smaller than the next one. So -1 is smaller than 0. -2 is smaller than -1. -3 is smaller than -2. And you can think of these in like really basic ideas or basic concepts like, would you rather have more or would you rather owe more? Like, would you rather have $2 or would you rather owe $2? And if you owe $2, you're in the negative value. You're in the negative value range. So let's go ahead and look at example number 1. And example number 1 asks us to make our own number line and to locate these different values on a number line. So the first thing I do, I'm going to try to draw a relatively straight line. It's not going to turn out good. Alright, if I try to draw a line, that's not that bad. Always going to put arrows on my outsides and put a line right down the middle. And this line right down the middle will always be 0. Alright, so let's go ahead and start putting these numbers. -4 is a negative value, so that means it's going to be on the left of 0. So we're going to go to the left 4 times. 1, 2, 3, 4. And this is where -4 would be. And this is -4 on a number line. 0 is already marked. It's actually the first thing we're always going to put on a number line. So this is going to be 0. And 2 is positive. So that means we're going to go to the right twice. 1, 2. And this would be 2. So for this problem, they just want us to locate these values on a number line. It's not really that difficult. Just remember 0 is always in the middle. 2 and all the positive values are always going to be on the right. And -4 and all the negative values will always be on the left. Cool? Cool. Alright, now let's talk about opposites. Two numbers are opposite if they are the same distance from 0 on the number line but in opposite directions. So let's go ahead and draw a number line again. So here I have a line. I'm going to put 0 on the number line, and let's go to the right, let's say 3 times. 1, 2, 3. The opposite of 3 would be 3 times on the other side of 0. So that would be -1, -2, -3. So the opposite of 3 is -3. So when we're talking about opposites, one way we can think about this is on a number line. How many spaces away from 0 and going the same distance on the other side. Another way we can say an opposite is just by changing the sign. We can say that negative values and positive values are opposites. Are opposites of each other. And that's one easy way to kind of remember that. Like if I ask you, what is the opposite of negative 5? Well, you could draw out a number line. You could go ahead and just draw out a number line and figure out, well, 0 is in the middle, and negative 1, negative 2, negative 3, negative 4, negative 5 goes right here. And we can figure out the same distance on the other side, 1, 2, 3, 4, 5. All right, so the opposite of negative 5 is just positive 5. All right. But you don't have to draw a number line every time. Basically, we can just switch the sign. Whenever they ask about opposites, it means that we can just switch the signs. Switch the sign from negative to positive, and vice versa. From negative can go to positive, and positive can go to negative. All right. So another example, like if I ask you what is the opposite of, let's say 12, well, the opposite of 12 is negative 12. And what is the opposite of negative 12? Well, it's just positive 12. They go back and forth, and these are considered to be opposites. Not too bad, right? The opposite of a negative number is positive, and the opposite of a positive number is negative. This is something you should have in your notes, but this is something we just discussed. And 0 is its own opposite, meaning there is no negative 0 or positive 0 because it's that dividing line in the middle. It's neither positive nor negative. It is its own opposite, and it doesn't have an opposite. That's one of those really weird specific numbers that just happens to come up in math. Cool. All right. So if you have this written down, let's go ahead and go to the next skill check. Write the opposite of each integer. So, kind of interesting that we're using the word integer here and we haven't clearly defined it. That's interesting. All right. What is the opposite of 6,040? Well, if we just change the sign, that would be the opposite. So the opposite of positive 6,040 is going to be negative 6,040. That's it. You're going to have questions like this on your homework. Let's do another one. What is the opposite of negative 6? Well, the opposite of a negative is positive. So the opposite of negative 6 is positive 6. Cool? Cool. So let's go ahead and define integers, because we just use this word integer. Write the opposite of each integer. We haven't really discussed what exactly an integer is. Well, integers by definition consist of whole numbers and their opposites. Integers consist of whole numbers and their opposites. This is a classic definition of something that whole numbers and their opposites. All right, this is something that will definitely show up on a pop vocab quiz if there ever is another one in this class. All right, so in this case right here, these are examples of integers. 1 is an integer because it's a whole number, so its opposite is also an integer. 2 is an integer because it's a whole number, so negative 2, its opposite has to be an integer as well. 3 and negative 3, 4 and negative 4, 5 and negative 5, and also 0 because 0 is technically considered a whole number. What we don't have on this list, things that are not integers, is there are no fractions, right, that can't be simplified to whole numbers. And there are also no decimal values. There's no decimal values that aren't whole numbers. So when we talk about integers, fractions and decimal values that cannot be simplified to whole numbers, they are not considered to be integers. Now, the positive integers refer to natural numbers. Natural numbers are also known as counting numbers. Counting numbers. So natural numbers, aka counting numbers. Those are the numbers you first learn about when you first learn how to count, starting with your hand, starting with number 1, 2, 3, 4, 5, and you start counting up. And remember when everybody's all proud that you can count to 10? Now they don't really care about that as much as understanding integers, positive and negative. Well, now you're on that track, all right? Because counting numbers are the positive integers. Negative numbers are the opposite of those natural numbers. So the opposite of 1 is negative 1. The opposite of 2 is negative 2, and so on. Cool? On a number line, the smaller of the two integers will be the one that's farthest to the left. So whenever we have a number line, the smallest numbers will always be on the left, and the largest numbers will always be on the right. So one test that we can see is which number is bigger, is which one's on the left is always smaller. So we have two examples right here. We have -7 and 5. So if I was trying to compare 5 to -7, which one is larger? All right, well, in this case, 5 is larger. Why? Well, because it's more on the right. It's a positive value, and all positive values are bigger than negative values. You can ask this question. Talk about baby bird for a second. Would baby bird rather have 5 worms or -7 worms? You think, how can the baby bird have -7 worms? Well, he owes worms to his bird friends, right? Well, he'd rather have 5 worms for himself, right? Would he rather eat for 5 days straight or not eat for 7 days in a row? Well, he'd rather eat for 5 days in a row. On a number line, the smaller the two integers will always be the one farther to the left. So in this case, if we have to compare -8 and -3, which one is larger? Well, -3 is larger because it's closer to the right. All right, would you rather owe $8 to somebody or only owe $3 to somebody? I'd rather only owe $3 to somebody. So -3 would be the larger value. Cool? Let's go ahead and compare integers. We are comparing two values right now, 10 and -1. So which is larger, 10 or -1? And we're going to write either greater than, or less than. All right, well, 10 is greater than -1. I'd rather have $10 than owe somebody $1. So 10 is greater than -1. What about -5 and -2? Well, out of these two values, -2 is larger. -5 is more negative. -5 on a number line would be over here, -5, 4, 3, -2. All right, -5 is to the left. It is less than. So now, if asked to reorder integers from least to greatest, we would go ahead and we could start by making a number line. I placed my numbers on a number line, and I saw that the number on the left is -8. So this is the smallest one. We're going in order from least to greatest. So the smallest number is -8. The next smallest number is -2. The next smallest number is 0, and the greatest number is 4. So if I had to reorder these from least to greatest, I have the most negative value first, and the most positive value last. That's it.